Hello everyone, thank you for your interest in my presentation. I'm Esperanza López Zendella, Associate Professor at the Department of Didactics of Mathematics of the University of Granada, and in the following minutes I will briefly present a piece of my research study on strategies and errors of lower secondary students when addressing a word problem. Mathematics is widely conceived as a problem-solving activity, and solving carefully selected problems is largely acknowledged as an effective method for developing mathematical competence. However, the domain of word problems has been for decades identified as an area of concern in mathematics education due to students' struggles in solving them. Research studies conducted with pupils consistently confirm that word problems are among the most challenging types of problems for students, as frequently reported by teachers. Multiple researchers have endeavored to better understand this phenomenon. The aim of the present study is to shed light on both the strategies and the errors of lower secondary students when addressing a word problem of the type whole divided into unequal parts, as well as to analyze the potential relation between them. We consider a word problem as a verbal description of a problem situation involving one or more questions that can be answered by applying mathematical operations and data presented in the wording of the problem. We refer as a strategy a way of approaching a problem in order to find a solution, and we call error any incorrectness or inaccuracy observable or inferable from a productions or performance. Here we highlight three previous studies to this regards. Concerning strategies, Jian and Chuang found that students from grades 6 to 8 use arithmetic, algebraic, modal, and unitary methods in their solving processes of word problems. Regarding errors, both Radwan and Wihaya found that the most frequent students' mistakes were related to understanding of the problem and mathematization. 79 students from grade 8 of a Spanish high school participated in the study. They were three class groups with the same mathematics teacher. The classroom intervention was part of a larger research project and included a pre-test and a post-test of 10 word problems each. 8 weeks elapsed between these two tests, time during which the teacher developed the didactic unit on algebra with her students according to the Spanish mathematics curriculum for grade 8. Each test was developed during a regular mathematics class time with a duration of 60 minutes each session. In this presentation, we show results relative to the analysis of the students' productions for the post-test problem shown in this slide. During the post-test, the students didn't receive any feedback about the suitability of their strategies, either the correctness of their answers. They were allowed to use calculator and encouraged to explain their solving processes, not only to include their proposals of solutions. For data analysis, we use an emerging categories approach. Our data analysis gave rise to the categories of strategies shown in this slide, where some of them are illustrated by figures inspired by students' productions. As for errors, we identify the ones shown here and also exemplified by figures inspired by students' productions. We highlight that more than 80% of students use arithmetic and pictorial strategies versus the 17% who formulated an equation. Only around 3% of students properly formulated the equation and obtained a correct response under this strategy. Around 17% of students made meaningless operations for the problem situation. Most frequent strategies was propositional reasoning based on pictures, often misrepresenting the data. This points out, in particular, the importance of mathematical maturity to avoid conceptual errors in pictorial representations. Showing and discussing with the students these frequent mistakes in regular mathematical classes could be definitely instructive for students, taking errors as opportunities to learn and build solid knowledge and competence in mathematics. Here we show some of the references cited during the presentation. Thank you so much for your attention. Comments and questions are more than welcome. Thank you.